Good afternoon, everyone. It's Ronak Shah here. I welcome you all for the Pure Nickel Alloys webinar. Basically, pure nickel alloys has have many advantages and it's have many applications in different industrial sectors. So let's begin that how these alloys, what are the grades, how it's differed from, and what are these applications, what is its improve like involvement in joining industries and all that. So let's begin with that. So if we start with this, let's begin with the tensions. We having our 60% shares of revenue generated from the temperature sensors, while 29% of shares of revenue generated from the different types of cables, and 11% of shares of revenue generated from the providing the heating solutions to the industry through the marathon heaters. We having a different sister concerns, marathon heaters, AST and equipment, which is locally built in Udaipur. We having our 600 employees, $42 million sales around the world, 75 countries around the globe we had been served, and 3 of our global locations presence. Let's begin with what are our plants is and how it's like, which are like their products. So if we go with the unit, temperature sensors unit, heater pyrometer unit, thermowell and furnace unit, nickel conductor cables and MI cable unit, and PVC cable units. We having our facility in Germany and in Indonesia, Jakarta, Indonesia. So both was developed in 2007, followed by 2017 respectively. These are our key products in temperature sensor sector. So we are the largest manufacturer of thermocouples, calibrations equipment. We are good in observations of pyrometers like laser pyrometers, thermal pyrometers. We having a wide range of variety of pyrometers. We also producing the thermocouple base of conductor, extension grade and compensating grades of conductors. We also having like cables. In cable divisions we are producing many types of cable, PTFE cables, PVC cable, ST cables, MI cables. Different types of insulations has been carried out in the unit facilities in Udaipur. We having heating solution divisions which provide like cartridge heaters, band heaters, annealing furnaces, oven, heating pads, and different types of heating solutions which have been served by the temperatures and through the marathon heaters. So let's begin with the PPT of pure nickels. What are the pure nickels alloys? How this compositional difference is going to cover? What are the proportional difference? What are the major applications? How it's playing joining industrial role, and how we can serve the industry. So let's begin with the pure nickels. Basically, there are the 3 different grades of pure nickel alloys: nickel 200, 201, and 270. This is also known as a alloy 200, alloy 201, and 270. These 3 of alloys are containing 99% of nickel. The first alloy contains 99% of nickel. The second alloy contains 99.6% alloy, and last is a 99.9% alloys. So if there is more highly purified nickel which having a percentageal difference which make the elements very ductile, which can reduce the end brittlement of brittleness. A part of that, when it's a creep ratio is a creep resistance, creep behavior is also high in high purified nickels. So we going to understand that how these three pure nickel grades are differ from each other. So if we go with the compositional difference, we can see there is a major difference has been observed in nickel. So if we go with the alloy 200, the nickel is 99%, in 201, 99.6, and 270, 99.9. While copper remains same in 200 and 201, while reduced in 270. All are the elements has been constantly stable in 200 and 201, while in 270 the other element like copper, iron strengthening elements like tungsten element, manganese and carbon, silicon and sulfur, which found very lower side. due to this high purified nickel. So if we go with the carbon percentage, if we see the carbon percentage having a major difference here, if we go with that, the carbon percentage here is like 0.15 percentage. This make it high carbon content nickel. This nickel is widely used for the like below 350-degree temperature. This is also so nearly same, while the carbon percentage is less because of it's remove the hydrogen embrittlements, and a part of that brittle fracture can be reduced through the carbon percentage. If we go with this, this carbon percentage is higher side in 270 with the high purity nickel. It's applicable for the higher side of use. This is how more 100 and 600-degree temperatures. So let's begin with the technical difference. So if we go with the density remains same, but due to high purification, the density in 270 is slightly high. The melting range is nearly same. The specific heat, which is heat required for the rising the temperature, so which is a little bit higher in pure nickel, while crucial temperature is little lower. Tensile strength is playing an important role in pure nickel as it's ductile. So tensile strength is always inversely proportional to elongation. So in 270, the 345 megapascal tensile strength has been observed, while the elongation has been 50%, nearly 50%. Twisting rate is also remains same. Coefficients of expansion remain same, while the thermal conductivity has been changed as the percentage of nickel improve, as the percentage of carbon reduce. So if we go with alloy 200, we see in the thermal conductivity is 73, while in 201 is slightly higher and 270 is very higher. If the thermal conductivity is improved, the electric conductivity is also improved. The resistivity, electric resistivity is proportional to thermal conductivity. So if the electric resistivity is 9.6, the in 8.5 micro ohm per centimeter square, it's observed in 201, while in alloy 270 we can see the 7.5 micro ohm per centimeter, which is make them very low electric resistance alloys. Let's begin with the major applications. Major applications of alloy 200. So basically, so nickel is there, so it's a highly corrosion resistance, which is used in DM waters, acid piping equipment, which is conjected with the alkyls, drum for the chemical storage, thermal industry, service up to 200, 350 degrees Celsius, approved by the Division 1 ASMA boiler and pressure vessel code. High thermal conductivity, rapid heat rate, defense industries, aerospace and missiles components, rocket motor and food processing equipment manufacturing. So if we go with the alloy 200, it's a similar range of temperature serving. So the temperatures are from the 350 degrees Celsius to 600 degrees Celsius temperature. It's widely used in steel making industry for the adding in as alloying additions in specialist chemical industry for the caustic soda, fluorine and chlorine content pipelines. And if we go with the alloy 270 applications, the electric industry, the fluorescent light component use electric resistance, thermometers, electronics industry, electronic cathode anodes, the thermal industry for heated parts and winding wires and heaters. So these are the major applications of different types of pure nickel alloys. Let's begin with the how it's playing a major role in joining industry. So if we go with the joining industry, the applications in joining industries are like a seal metal arc welding, where you can use as electrode 200 or 201, while gas metal arc welding as a filler metal 201. So both is used as a filling metals in both joining applications. It's also using in brazing applications. Let's begin with what are our supplies. We having our supplies wired form and rod form, manufacturing gas per the ASTM and ASM specifications, which is size from 0.16 mm to the 8 mm, while the surface finish is the luster finish observed.